Dart skill presents ordering and comparing fractions. We know that on the number line, the smaller numbers come on the left and the larger numbers come on the right. So if we have a negative 5 over here, and let's say 0, and let's say 5, 10 like that, negative 5 being on the far left is the smallest of the lot, and 10 being on the far right among these numbers is the largest of the lot. And we could say 0 is more than negative 5 because 0 is to the right of negative 5, and then 5 is to the right of 0, therefore 5 is larger than 0, and finally 10 is to the right of 5, so we have 10 is larger than 5. And then fractions are also numbers on the number line, just that they are between the integers. So you could have a fraction here, you could have another fraction here, perhaps another one here and another one here, and so on. And because we could plot fractions on a number line, it goes without saying that fractions can also be arranged from smallest to largest, smallest on the left and largest on the right. So let's now try and understand how to compare and order fractions from smallest to largest or largest to smallest. It helps to remember that when we write a fraction, for example 2/3, the fraction bar is actually nothing but a division, and therefore this is equivalent to the division problem 2 divided with 3. Similarly, the fraction 4/5 is equivalent to the division problem 4 divided with 5, and so on. So the numerator is the dividend and the denominator is the divisor. The numerator is the dividend and the denominator is the divisor. So if we have two or more fractions on the same numerator, let's say we have 2/3 and then we could have, let's say, 2/5, and let's have a 2/7 and perhaps a 2/9, and also let's go for a 2/10. Essentially you are dividing the number 2 with each one of these different numbers. So this is 2 divided with 3, this one's 2 divided with 7, this one's 2 divided with 5, and this one's 2 divided with 10, and this one's 2 divided with 9. Given the same dividend, in this case 2, the smaller the divisor, the larger the value of the answer or the quotient, and therefore the larger the value of the fraction. And larger the divisor, the smaller the quotient or the value of the fraction. So if we were to arrange these or these from smallest to largest, the smallest is this denominator with 10. So this becomes the smallest. Let me say that's first 1. Number 2 would be this one, and this would be number 3, and number 4, and 2/3 is the largest of them all, number 5. So if we were to arrange them from smallest to largest, you write 2/10, 2/9, 2/7, 2/5, and 2/3. On the same numerator, the smaller the denominator, the larger the fraction is. And let's just use the same logic of division to arrange and order fractions that are on the same denominator this time. Let's say we have several fractions on the denominator 11. Something over 11, something over 11, something over 11, something over 11, something over 11. Which means they're all divisions in which the divisor is 11. Let's say we have a 5 over 11 and then a 1 over 11, and let's say a 6 over 11 and 10 11s and a 7 11s. So this time if you want to change each fraction to a division, like I said, The divisor is 11, so you have 11 outside on each one of them. 11, 11, 11, 11 and 11. And then you have a 5 divided by 11 for this one, 1 divided by 11 for this one, 6 divided by 11 for this one, 10 divided by 11 for this one, and 7 divided by 11 for this one. And there is no price guessing that if you are dividing a bunch of numbers with 11, the same number outside, the smallest dividend is going to give you the smallest quotient or the value of the fraction. So this time 1/11 is the smallest, or let's call that 1, smallest to largest. This one is also smallest to largest. So 1 indicated it's the smallest. Same over here. 1/11 is the smallest, followed by 5/11, so that's 2. And then we have 6/11, 3, 4 and 5. And then the final question is, how would you compare fractions that are on different numerators and denominators? For example, how would you compare 2/3 with 3/4? Neither the numerators are equal nor the denominators. In this case, the idea is to use the concept of LCM, least common multiple, and write down equivalent forms of these fractions so that either they're on the same numerator or on the same denominator. So if you look at the two numerators 2 and 3, the LCM of 2 and 3 is 6. So if you want to change this 2 to a 6, you want to times this with 3. And if you times the numerator of a fraction with 3, you got to do the same with the denominator, times with 3. And then if you want to change this 3 to a 6, the idea is to have a 6 on the top on both fractions. So you multiply the 4 with the 2 as well. And now the two fractions that we have over here, 6/9, that's equivalent to 2/3, and 6/8, that's equivalent to 3/4. They're on the same numerator, different denominators. Larger the denominator, smaller is the fraction. So we could say 6/9 is smaller than 6/8, but 6/9 is just another form of 2/3, and 6/8 is just another form of 3/4. So we could say 2/3 is smaller than 3/4. And you could have actually solved this same problem, compared 2/3 with 3/4, by changing the denominators to the same number, their LCM. And the LCM of 3 and 4 is 12. So to change 3 to 12, times it with 4, and you got to do the same on the numerator. Change 4 to 12, times it with 3, do the same on the numerator. So the equivalent fractions we have are 8/12 for 2/3 and 9/12 for 3/4. Now these two fractions are on the same denominator as in this example. So you are essentially dividing 8 with 12 and 9 with 12. Which one is going to give you a larger answer? Obviously 9/12, or 9 divided by 12, is more than when you divide 8 with 12. So 9/12 is more than 8/12, and 9/12 is an equivalent form of 3/4. 8/12 is an equivalent form of 2/3. So it goes this way. It's the same result you would have got by changing the numerators to the same number.